All right, let's take a look at 9.1, number 35. Let me zoom in a little. Okay, 9.1, number 35. Okay, so it says high-speed internet access. You know what? I think we may have done this exact example in the notes. Well, maybe not exactly, but something similar to it. Anyway, it says a researcher wishes to estimate the proportion of households that have broadband internet access. What size sample should be obtained if she wishes the estimate to be within 0.03 with 99% confidence? If, in part A, she's going to use some prior estimate, and in part B, she doesn't have a prior estimate. So in part A, since she's using a prior estimate, the way that we estimate the sample size she needs is by using this formula. We say n is approximately p hat times q hat, or I think in the notes I said p hat times 1 minus p hat, but same thing, right? Q hat is just 1 minus p hat. So it's p hat times q hat. What is the formula? Give me a sec. P hat times q hat times z sub alpha over 2 over e squared, where e is our margin of error and p hat is our prior estimate. Okay. So okay. So part A, now it says she uses a 2009 estimate of 0.635 obtained from the National Telecommunications and Information Administration. So in part A, P hat is 0.635. I'm going to say this is about 0.635. Q hat would be 1 minus that. So 1 minus 0.635 is, 0.365. That's kind of trippy. And then we need z sub alpha over 2. Well, it says in this example that she wants to be 99% confident. So just as kind of some scratch work, I'm going to say, her confidence level is 99%. That means that alpha is 0.01, right? 100% minus 99%, 1%, which as a decimal would be 0.01. Okay, so then z sub alpha over 2 would be z sub 0.005. So we can go to StatCrunch and figure out what that number is. So going to StatCrunch, we would use the normal calculator and say stat calculator's normal. We leave the mean and standard deviation at 0 and 1 respectively. We want an area to the right, and we want that area to be 0.005. So there's our critical value. It's about 2.58. Okay, so I'm going to say, so I've done z sub alpha over 2 now. It's about 2.58 divided by the margin of error. What's the margin of error? Well, it says what size sample should be obtained if she wishes the estimate to be within 0.03. right? She wants the estimate to be within 0.03. So that's our margin of error. Okay, and then we plug that stuff into our calculator. Let's see what we get. So I'm going to type it in exactly the way it looks. 0.635 times 0.365 times, I'm going to open up a set of parentheses and say 2.58 divided by 0.03, close the parentheses, and square that. And I'm coming up with 1,714.21. And then we would round this up to the nearest integer. So rounding this up to the nearest integer, we would get 1,715. Okay, and that would be the answer that we get. Now the answer, if you look at the answer in the book, the answer that the book is getting, so let me circle that, that would be an acceptable answer. The answer that the book is getting is n equals 1708. And I suspect that the reason for that is because they probably rounded this number differently. Instead of saying 2.58, maybe they said 2.576, you know? Maybe they rounded this to 3 decimal places instead of 2 decimal places or something like that. So just out of curiosity, I'm going to replace the 2.58 here with 2.576 and see if I can get closer to what the book is saying the answer should be. So let me go back and replace the 2.58 with 2.576, and yeah, I get closer. I still don't get quite the same thing. I get n is approximately 1708.9, so really we would say n equals 1709, right? It's still different than what the book is getting, but it's closer. I suppose it's possible they just used this entire number, but now that I'm thinking about it, I think that actually what they did is they probably used a chart in the back of the book. Instead of using StatCrunch, they probably got this number from a chart. And the problem with that is that the chart that they're using is not as accurate as StatCrunch is. So actually our answer is better. This answer is better than that one, right? 1709 is a better answer than 1708. When you use a chart to get the value, you actually get 2.575. So let me go back and replace 2.576 with 2.575. And sure enough, that gets me 1707.57, which when you round it to the next whole number is 1708. That's not a good answer though. This is a better answer. It's more accurate. Okay, but anyway, that's part A. And you know, I do apologize about that. That's kind of how these exercises go in this particular section, because again, the book is going to sometimes use StatCrunch and sometimes it uses like charts, which are sort of old-fashioned and not as accurate as StatCrunch is. So as long as you're in the ballpark, you can be pretty sure that you're doing the work correctly. That may not be very comforting because it's hard to tell how close you need to be, but anyway, if you got 1715, then your work was totally fine. Looking at part B real quick. In part B, she's not going to use any prior estimates, and so the formula is going to be different, right? So instead of using this formula, this is the formula that you use when you have a prior estimate for the proportion. If you don't have a prior estimate for the proportion, then you just say n is approximately 0.25 times z sub alpha over 2 over e squared. Same values for z sub alpha over 2 and e. So, you know, we'd say n is approximately 0.25 times, well, if we're going with what we got from StatCrunch, we would say 2.58. Oh, sorry, for E, we should have 0.03. If we're going with what the book is going to use, the book is going to say 2.575. Let's see what we get. So 0.25 times 2.58 over 0.03. And I've got to square that stuff. Well, I get 1849 on the money here. The book is saying that you should get 1842. I bet that you get 1842 if you use this value. Let's see. So I'm going to replace the 2.58 with the 2.575. And yeah, you get about 1841.84. So when you round that to the next whole number, 1842, right? Just like the book says you should get. Anyway, I hope that helps. I know it's a little frustrating because, you know, the book is sometimes using charts and stuff to get the values, and we're using StatCrunch every time. But anyway, yeah, hope that helps.